So this is the array version here. I want to redraw it as an area because it's easier to draw as an area. And then when I redraw it, I don't worry about drawing all the lines. I only make the lines that go with my whole numbers and my end fractions. So my picture's going to look like theirs, but with just everything stuck together. And if you think about our toys, I can see all of the flats, I can see all of the longs, and I can see all of the units. So I see, let's see, 2 holes and 4/10 in the first row. In the next row down here, I see 6/10, and then I see a group that's 4 by 3, but those are 12 what? Hundreds, because those little things are 100 to the whole. And so then I can combine stuff together. These two give me a whole. And so in the end, I can get my 3 and 12/100ths. Does any trading in go on here secretly? Yeah, so first, with the tenths, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm just going to make a note on the side that I'm going to trade 10/10 for 1 whole. Any other trade I can make? Yeah, the 1200s, I could take 10 of them. So all these are all hundreds. I can say take 1, 2, 3, 4, 5, 6, 7, 8, 9. Take 10 of those and trade those into a tenth, because I do have that tenth show up right there. Because I could look at that as 1/10 and 200ths. And there's 2 ways to think about a decimal, in pieces or in total. So red. So I'm also trading 10/100ths for 1/10. That gives me that right there. So we're going to do some other problems after this one, and here's what I'd like. I'd like a picture that's an area. If you like drawing the array version instead up there, that's totally cool. I don't like drawing it because there's way more lines, it takes longer, I'm not as neat. Here I can draw this way neater and way easier, so I prefer to draw it as an area. You with me on the distinction between the array and the area? Okay, so you decide which way you want to go. And then as far as writing out some math to go with it, I'd like you to try and think about it this way right here. So the way I'm viewing that is I'm taking this 1 right here and I'm viewing it across to the other side. So I'm getting a group of 2 holes and a group of 4/10. And then I look at the third 3/10 coming across, and that leads to 6/10 and then the 12/100ths. One more version of this, write it out like you normally would. 2 and 4/10 times 1 and 3/10. And I guarantee all of the pieces here are living in this when I do that. So let's just take a look at me doing it. First thing I do is 4 times 3, right? And I don't just come and write 12 underneath there. What do I really do? I trade or I carry that 1 up there and put the 2 there. And then I say 3 times 2 is 6 plus 1. Now here's a question. This 3 looks like a 10th, right? And this 2 looks like a whole number. What's that 1 up there? 1 what? Is it 1 whole or is it 1/10?
That's 1 whole because 3 times 8. Oh.
What is it in the picture?
It is.
Yeah, because it's 1.2 because 4.
Mind blowing, isn't it? What is it? 1 what?
It would have to be 1/10.
Yeah, it would have to be 1/10. It came from down here, right? That 1/10 right there. And when I take a 10th times a whole, what's 1/10 of a whole? It's still a 10th. Yeah, so when we take 3/10 times 2 whole, we end up with 6/10 right there in the picture. So that is really 6/10 plus 1/10. Say that right? 6. Sounds weird. And what's it coming out as here? 7? There's 7 living in here anywhere? In the bottom row, color. There's the 7/10. Now we're not writing a decimal in there, we're ignoring the decimal for now. All this stuff is hiding in the background. Do I expect kids to get that? No, I don't. What do I do next? I put a placeholder in, 0 is the best choice for a placeholder. Don't leave it blank, don't put an X, put a 0 in. And then move on to 1. 1 times 4 is 4, 1 times 2 is 2. And then we reconcile this. 2 and nothing is 2, 7 and 4 is 11, carry the 1, 2 and 1 is 3. So it's too hard to track all the places when you're doing it in our standard algorithm right here. So we have 2 things going on at once here. 1, we just want kids to get the idea that they have to adjust the place value. In the end, by saying there's 1, 2 places there, so there better be 1, 2 places down there. But at least for a little while, we want to play with the kids with some simple examples where we can draw the pictures and count stuff. So for the kids, I would expect them to be able to draw this picture right here and then count up what the answer is. I would expect them to eventually be able to do this. This part right here, maybe some kids would have a hard time with that. Other kids can do it. It just kind of depends on the group. But you're going to see these pictures in all the textbooks now for decimal multiplication. All right, so 3 things for each problem. Draw the picture, write out the expanded version, and then write out the standard version of the multiplication. And then I think they give us some more to do down below.
Do you have graph paper?
Oh yeah, I just printed it out. I'll go grab it, yeah. So for each of these 4 problems right here, draw the area, write out the expanded version, and then write out the standard version just to compare them. I'll get the graph paper.
The addition one is the expanded.
Yeah. So this
Here's-
expanded.
Oh, and then you wanted to see the lattice multiplication.
Thank you.
Let's take a quick look at the lattice and then we'll continue this. And we'll finish it up next class. So I'll do the lattice multiplication on the problem we just did, 2.4 times, and then to do the lattice, I write the 1.3 coming down like that. And then I draw the grid And there's gonna be a row for each number and a column for each number going the other way. And then we draw our diagonals coming through. And Emily, this may not be have been in one of the sections I told you to look at. I can't remember. You remember seeing this in the book? No, this is kind of a cool way to multiply. So ignore the decimal points for a minute. 4 times 1 is 4. That just goes down there. 4 times 3 is 12. It would be written like that. So the 1 digit always goes in the lower part. If there's a tens, it goes in the upper part of the triangle.
I always just put a 0 because it.
Yeah, you can put a 0 in. So you could call it 0, 4. 3 times 2 would be 0, 6. No 10, 6 ones. 1 times 2, you can call it 0, 2. And then you just follow those diagonals. So my diagonals come down like this. So for the endpoints here, I'm going to get a 2, 6, and 1, and 4 is 11. So I have to carry a 1 to the next diagonal. 1 and 2 is 3, and there's nothing over there. And to determine the decimal point, you just got to count the places back here. So there's 1, 2 places there. There's going to be 1, 2 places here, and then put in the decimal point.
Can you like match where they come together? Like the decimal point, top one comes down, the other one, and then where they meet? Does that make sense what I'm saying?
Where the decimal points meet, like track it down that way and that way?
Yeah. I mean,
I don't
I don't know.
think, let me do another example and see. I never thought about that before. That's a good question. Let's try using just a couple more digits. Suppose we had 2.56 times 3.4. So if we were going to lattice this sucker, we'll use a different color when the decimal comes down. And then diagonals. So let's see, we get 18, we get 15, and we get 6, and then we get 24, no, yeah. And then we get 20, and we get 8. And we come down with 4, 10, 8, 9, 10, 15, 16, 17, turn over 1. 8. And so if the decimals kind of meet here, does it always work to follow that diagonal and find the decimal point? It worked in those 2 examples. I'll have to think about it some more as to see if that always works. That's an awesome question.
because I feel like that's how my 4th grade teacher taught me, but that was a long time ago, so
Yeah.
I could be completely wrong.
Holy shit, I think it does. Wow, my mind is blown. Okay, so I think it does, but I don't have a clear explanation for it in my head. So give me a couple of days and I'll try to come up with a clear explanation for why. So I'm pretty sure the answer is yes. Wow, that's cool. I don't know if I told you, I learned something new in this class every year, and I've been teaching this for like 20 years. So I'm always amazed at that. Always something new to learn. Yeah, so for example, this is what, I mean, what if it was, instead of 2.56, what if it was 25.6? Then the decimals would converge here, and we follow down and want to put the decimal point there, and there's 2 decimals there, so there'd be 2 decimals there, and it would be in the right spot. So I just got to come up with a coherent explanation as to why that should always be the case. It seems to me that it's gone to be.
I mean, it still adds up to your way of doing it, but.
Yeah. That is so awesome. Thank you. Good job. What do you think, Kristen?
I don't like lattice.
You don't like lattice? That's one of my favorite multiplication ways ever.
I failed it on every single test.
You
I
did?
did.
Oh my gosh.
I don't get it.
Okay.
I get it for about 30 seconds.
And then it goes away. Yeah. Yeah, it could be just lack of practice. Like
Oh, I tried.
because for me, sometimes it takes so many times to practice to get used to something.
It takes a lot for me to put together the standard.
Oh, really? The standard
I
is
don't know,
really
it's just
easy
like
for
a
me.
bunch of different, I don't know. This one just boom, boom, boom.
I like the standard. I can do that one almost in my head. But
Yeah.
I would sit, so I had 3 hours between each class.
Oh, you need to practice a ton of these?
I did, and every
Okay.
single time I got it wrong.
Oh.
And I think I had scratch paper for the test, and I ended up throwing half of it away because there was like 3 pages front and back of one problem, and I got a different answer every time. I just don't get it.
All right, I'm going to draw one more of these before we part. What was the second one? 1.4 times 4.2.
I don't really get the expanded addition for multiplication, like that problem that you
The
did.
one we just did?
Yeah.
Okay, I'm going to repeat that right here for this problem.
I mean, I got it when you first said it, but now it's like trying to do it on my own. I don't quite get it.
Yeah, I'll draw it out for this one. All right, ready for my explanation of it, Kristen?
Yeah.
So you got the grid down, right? The area?
Yeah, I have.
Yeah, so what I do is I look at this and I can say, okay, there's the whole number part on this side and there's the fraction part.
Okay.
So I just follow the whole number part across. So notice I separated here with a different color for the whole number versus the fraction.
Okay.
So what do you see in the first group here?
4.
4 wholes, right?
Mm-hmm.
And then what do you see in the second group here?
2 tenths.
2 tenths. Okay, done with that one. So then I move down to this one right here. What do you see in the first group in this bottom row?
16 tenths.
16 tenths, which I could write like that.
Okay.
And
8 100ths.
8 hundredths. Yeah, and that's all the expanded form is. Oops, place there. And so then I can regroup that to say, okay, there's the 4 all by itself. These guys are going to come to 1 and 8 tenths. And then I have 8 hundredths here. And then I can reconcile that into 5 and 8 tenths and 8 hundredths. The answer's got to be 5.88.
So then I have a quick question.
Yeah.
I did mine with the 3.
3 with a 2.3.
So then there's nothing there, so I wouldn't do anything for the lower.
Yeah, so you only have one row of stuff going there. So on this one, I see 6 going, and I see a group of 6, and then I see a group of 3 by 3.
So 3 by 5. Oh, yeah, the 3 by 5, because if you take the half, I just.
So you drew tenths in there, but there was really no need to.
Oh.
So here's how I would have drawn that one. 3 by 2.3, right?
Yeah.
Okay, so you have, let's see, the 3 came down, so 1, 2, 3, and then 2.3 goes this way, 1, 2, and then 1, 2, 3. That. So this is the entire area.
Mm-hmm.
So without graph paper, the first thing I do is I block off the whole thing. Uh-oh, and there we go. And then I make the marks for the whole numbers.
Oh God, I see what I did. I could have left it as tens.
Yes, there you go, yeah.
Yeah, tens instead of hundredths pieces.
And I don't need to go across with hundredths this way or tenths that way, but I really should come down here with these tenths. So this expanded is much smaller because I only have 2 groups of stuff. I have this group right here, so there's 6 holes. And then I have a group of 3 tenths that way by 3 holes that way, so there must be 9, and those 9 have to be tenths.
Okay.
Yeah, so this was just way simpler. That's all there is to it. So 3 by
So in my
2.
addition, can I
3.
still write it the same way? Because I broke it down and added them up.
Yeah, that's okay.
Okay.
Yeah, so you have 90 hundredths, which is 9 tenths. Yeah, that's cool. And then back to this one right here, the other thing I want to draw in is the standard way of doing it. So 1.4 times 4.2. And I said slang kind of on purpose there, because when we do the standard method, we really don't think about place value to the very end. I just say 2 times 4 is 8, 2 times 1 is 2, placeholder, 4 times 4 is 16, carry the 1, 4 times 1 is 4, plus 1 is 5. Then I bring it all together. And then I have to decide 1, 2 places in my numbers, so 1, 2 places in the answer. So I'm hoping to see something like this for each of them. So this is my problem number 2.
So we don't have to do any explaining. It's just the 3 steps you want us to do.
Yeah, you don't have to do any explaining on this one. Just draw that out, make the expanded version, and then make the regular version.
Want us to label each? Like expanded, standard?
No, that's okay. So this is what we call expanded. And this is what we're calling the standard algorithm. And we are over time on Fun with Math. You guys should all stop working and go enjoy the rest of your Valentine's Day. You guys have classes tonight?
Nope.
Yes and no?
I have
You're
one
done.
more.
One more.
Yoga.
Yoga, that's a good class to go to.
I need my husband to go with me, but I made him go with me once.
Yeah.
And he's not impressed.